We'll sort of go through a little demo of the IndiGBERT model. So let me just walk you through certain examples. What you're trying to do with the notebook is sort of to give you a sense of how to use some of these models. So the first thing is, of course, to get the tokenizer for our language models. So these are the tokenizers for IndiGBERT v2 alpha. Okay, let's now look at what the model is doing. First of all, what the tokenizer is doing. When you give an input sentence, so here you have an English example actually, but we could take a example in some other language as well. So this is not what is exactly fed into the language model, right? So it's first tokenized using what is called a sentence piece model, subword model, so that you can have a fixed vocabulary of I think this model is, I don't remember, probably 100 or 200k vocabulary items, right? So that's the finite vocabulary that we work with. And once you have, so what you do is you take the sentence, you tokenize it. So you can see in this case, yeah, all these are very common words. None of them is getting split up. So these are all part of the vocabulary. Maybe we should take some other city. Okay, so for example, Thiruvananthapuram being a fairly long word, it's not part of the vocabulary and it's broken up into a few parts. Okay, right. So that's the first step. So this is what you will feed into the language model. And so we'll see first, before we do anything meaningful, we'll see what the language modeling is doing. So what happens if you just feed in some text into the language model? This has not been, of course, trained for any particular task. All it has been trained for is predict missing words. That's how the language model is trained. So you blank out a few words and try to predict it. So that's what the language model can do. So let's see if it can do that. So here, so you have again, like, yeah, Delhi is the capital or something. What does it predict? Okay, it was able to predict off, just I think fairly straightforward for this model. There's a Hindi model, Hindi example as well. Okay, I ran it a while back, so I'll not run it again. So here, what was blanked out? So Delhi Bharat ki, you mask out one word here, Rajdhani, but what you actually get the model predicting is Sarkar, which is not correct, but the model has maybe some notion of semantic similarity. So the government resides in Delhi or something. So anyway, so the model is sort of able to predict a few words. Now let's see if we can do something useful with this, right? So can we run a sentiment analysis system? So let's first go through a model which is already trained, okay, and just sort of see how to use it. So here we have already trained a sentiment analysis system on the English Amazon reviews dataset, okay, and we'll demo that sort of. Okay, so once the model is, so to use a classification model, of course, you have to use the corresponding class for sequence classification. And once the model is downloaded, for a new input, you basically have to tokenize it and feed it to the model. So tokenize, followed by feeding it to the model, getting the logits, and then finding the class with the highest probability. So in this case, let's see what it does. Well, it's a good thing. I suppose it's a good thing that we have AI for Bharat inaugurated in IIT Madras. We'll take a more interesting example, and this is Hindi. So this is the same model trained for English, but we are doing evaluation for Hindi. And so the sentence input is something like Bahubali dekhne mein maza nahi aaya, and yeah, it predicts that it is negative. So the point to note is this model has not seen any Hindi sentiment data. It's only trained on English sentiment data, but it's able to fairly do that well. There's another example about Bahubali being a good movie, and it again works out well. Okay, so that was about one kind of problem, which is a classification problem. So you are just predicting binary labels. Yeah, next, similarly, Hugging Face does provide you classes for doing question answering. And so we also have a pre-trained model for question answering on the TDQA dataset. This is again, I think, this is for Bangla. So yeah, again, I will not go through kind of loading the model again. I think it's the same process, The only difference is that now you have two inputs, question and context, for in the case of question answering, which you feed to the model, and the model can predict the span in the paragraph which corresponds to the answer for the question, right? So that's what this example is about. So there's a Bengali example, there's a Telugu example. Let's now see how to train, or rather fine tune a model actually for some task that you are interested in. Okay, so for this what I will do is take the multi-NLI dataset. So this is the natural language inference dataset for English, a standard dataset, and fine tune it for this task. So the task is given two sentences. You have to say whether sentence 2 is implied by sentence 1, or it is a contradiction, or there is no connection. Right? So it's a three-way classification problem. Okay, so again a classification problem. So we need to do everything to train it. So we need to, first of all, we need to load the data set. Okay. The next step is of course to have a tokenization function which can tokenize the data. So there are two inputs here, the premise and the hypothesis. So this is an example of a task which needs two inputs. Okay, so let's do a bit already. It will take a while, I think. Meanwhile, I'll walk you through. So yeah, we have the tokenizer, and then we create the shuffled data set for loading, and then now, okay, before training, the first thing we need to do is load the pre-trained model, IndicBERT v2 alpha. We set up the metrics for evaluation and all the training arguments. So number of epochs you want to train, the optimizer you want to use, and things like that can be passed as training arguments. And then you kind of invoke the trainer. So the trainer is given the baseline model, the various arguments for training, the training data set, and the evaluation data set, and the metrics to compute. So what I think this is, so you create a small example with just about 1,000 examples. So let's see if it can run fast. Then we've just taken a small sample of 1,000 examples because we'll just do a small one now, but you can of course train for the entire data set. And now we load the language model. This will again take a while. Training started for this model. I think we just set up for a very few number of examples and epochs, but you can sort of see the sense of what it's doing. Right, so kind of this notebook you can go through and try on out on your own. So essentially shows you how to load any of the pre-trained models that we have for sentiment Q&A. Plus you can fine tune it, do zero-shot evaluation. So you can just follow this, and of course I'll also play around with the language model. I think for convenience we just took a few English examples, but you can play around with any of the 22 Indian languages and see what it's doing. So we are using the auto tokenizer.